My friends, this is about to get easy, but I am kind of going to drag you through the mud just a little bit, just for these last two, and then we'll talk about how easy this will be. The third degree Maclaurin polynomial here would need to have everything that p sub 2 had. Which actually I suppose I should write it kind of in terms of f, because what I'm trying to build you toward is kind of seeing a pattern that will be really easy to memorize, which is how this becomes easy. Anyway, so this f stuff that I keep writing, that's trying to get you to the shortcut. Okay, so I had to have everything that p sub 2 had, but we also need it to agree up to the third derivative. So let's see, if you were thinking f triple prime, that is, of 0 times x cubed, then you pretty much had it. But I'd like to make sure that we're okay with basically needing 6 down below, or 3 times 2 down below there. And so let's simplify it. And then if you're not totally sure yet why the 3 times 2 or 6 needs to be there, we'll make sure you're good in a second. So let's fill things in. So f of 0 is 1. F prime of 0 in this case times x was just x. F double prime of 0 times x squared over 2 was 1/2 x squared. And then this last term here, f triple prime of 0 would still be 1. And so you'd end up with 1 over 6 times x cubed. And so remember that the derivative of this has to be the previous one. And so take the derivative of 1/6x cubed, the 3 comes out, multiplies by 1/6, and you get this 1/2 that you see here. And so there you go. Or really, you could, in this case, just think about antiderivative of 1/2 x cubed, and then get the 1/6x cubed, or sorry, 1/2 x squared, and get the 1/6x cubed. Okay. And then p sub 4 of x. So this fourth degree polynomial that has, the y coordinate in common, the first derivative. Oops, I keep writing x when I mean 0. The first derivative in common, it would have the second derivative in common, it would have the third derivative in common, and we also want it to have the fourth derivative in common. So what would that fourth degree term be? Remember, when you go past the third derivative, you would put the number of derivatives that you want in parentheses. So we would evaluate this, multiply it by x to the fourth, and what would need to go in the denominator for this one? So if you think about antiderivative on that last term of the third degree one, you would end up with 4 times 3 times 2 on the bottom there, or 24. So simplifying this beast, we would end up with 1 plus x plus 1/2 x squared plus 1/6 x cubed plus 1 over 24 x to the fourth. There we go. And how many terms would we need to make it so our polynomial is e to the x and doesn't have any of these big errors that you'd have? That's right, we would need infinitely many terms, which is where we'll go eventually with all this stuff. So, but infinitely many terms is not nearly as scary as it sounds, right? Because it's just a matter of establishing a pattern and then throwing on a plus ... So it's no big deal. So hopefully that makes sense. Okay. So I feel like you're ready to see the pattern. I wanted to point out, if you didn't notice already, that 4 times 3 times 2 is just 4 factorial. 3 times 2 is just 3 factorial. 2 could be thought of as 2 factorial, and it wouldn't hurt anything. f prime of 0 totally could have been divided by 1 factorial, and f of 0 totally could have been divided by 0 factorial, because by definition, 0 factorial is just 1. So notice that in every single term of these polynomials, you have a pattern. You have the degree on x matches the number of derivatives you've taken, and it also matches the base of your factorial in the denominator every single time. So, and that's when things get easy. It's when you start noticing that pattern and when you memorize what we're about to write in this bubble. So get started on writing this. The definition, one of the two big definitions of this lesson is if f has n derivatives at x equals 0, then the polynomial p sub n of x, which is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over, and you can say 2 or 2 factorial, nobody cares since it's the same, plus f triple prime of 0 times x cubed over 3 factorial. This time you need the factorial. And you would just, keep up at that until you get to the degree that you've been asked for. And so you keep going until you take the nth derivative of f and evaluate it at 0, multiply it by x to the 4th, and then divide that, x to the nth, and then divide that by n factorial. And that would be called the nth Taylor polynomial for f centered at x equals 0, also known as a Maclaurin polynomial. Okay, so now that we have that, what I wanted to do is show you how easy this can be, because in part A, I kind of drug you through the mud a bit and made you think harder than you really will have to. And so for part B, I wanted to kind of like start from scratch almost, and using this, what we see here in the bubble, have you see if you can find the nth Maclaurin polynomial for f of x equals equaling e to the x. So, yeah, I think I'll go ahead and just leave you to it, and then you can check with me in the next video.